Alright, let's get our giddy up on. This is Unit 4, Worksheet 1A, Midsegments of Triangles. This is Mr. Trutna. Okay, we'll just call me Mr. T. This is for all periods that I teach Math 2. Okay, so what we're going to be doing is we're going to be applying the theorem that we actually call the midsegment of a triangle theorem, which says the segment joining the midpoints of two sides of a triangle is parallel to the third side and is half the length of that third side. Okay, so we're going to prove the midsegment triangle theorem, and we're going to use coordinate geometry to prove it. All right, so in number 1, using triangle JKL, you can see over here we have triangle JKL. We're going to answer the following questions. We're going to find the coordinate of the midpoint of J and L, and then we're going to label it point M. Now, as you can see, this is the midpoint formula right here. So here's how we're going to do this. So we know that point J has coordinates of 0, 0, and we know that point L has coordinates of 2 and 6, okay? So what we're going to do is we're going to label this 0 as x1, this 0 is y1. That means that's my first x value, my second y value, or my first y value, excuse me. We're going to label 2 as x2 and 6 as y2. And then what we're going to do is we're going to substitute these numbers into this formula to find the midpoint, which is going to be m. So that means m is going to be x1 plus x2, which would be 0 plus 2. And then we're going to divide by 2. And then we're going to put a comma because we're finding the coordinates. Then we're going to go y1 plus y2, which would be 0 plus 6. And then we're going to divide that by 2. So working this out, we get 0 plus 2 is 2. 2 divided by 2 is 1. Comma, 0 plus 6 is 6. 6 divided by 2 is 3. So you can see that M has coordinates of 1, 3. So that means if I go to my graph and if I go over 1 and up 3, that point right there, which we'll refer to as M, that is the midpoint between J and L. Okay? In part B, we're going to find the coordinate of the midpoint of J and K. So here's J, which once again has coordinates of 0, 0. And then we're going to use point K, which has coordinates of 4 and 2. And then we're going to use the midpoint formula to find the coordinates of the midpoint between these 2 points. We're going to label it N. Okay? So my x1 value is going to be 0. My y1 value is going to be 0. My x2 value is going to be 4. My y2 value is going to be 2. And then I'm just going to substitute these values into the midpoint formula to find N, which is going to be the coordinates of the midpoint of JK. So I'm going to go 0, x1 plus 4, x2. And then I'm going to divide that by 2. Then I'm going to put a comma because I'm finding the x and the y coordinates. Then I'm going to go 0, my y1 value, plus 2, my y2 value divided by 2. Working that out, we get 2, comma 1. So the coordinates for the midpoint N is over 2, up 1, and you can see we have N right here. Okay, so that means M is a midpoint, N is a midpoint in a triangle, and then if I connect that segment, okay, that segment right there is what we call a midsegment. Okay, and then this theorem is telling me that the segment joining the midpoints of two sides of a triangle, notice these are midpoints of two sides of a triangle, it's parallel to this third side, so that means MN is going to be parallel to LK, and it's half the length. So that means however long MN is, it's going to be half of however long J to K is. Okay, so that's how that's what we're doing. And so what we're going to do is in part C and part D is we are actually going to prove that theorem. All right, so I'm going to zoom it out just a little bit so we could see it a little bit better. So in part C, we want to find the slopes of MN and LK. We're going to use the slope formula, which is right here. We went over this in class, y2 minus y1 over x2 minus x1. And then we're going to justify mathematically why they are parallel. So the first thing that we're going to find here is we're going to find the slope of MN. All right, so how do I do that? Well, I'm going to take the coordinates of m, which are 1, 3. I'm going to take the coordinates of n, which was coordinates of 2 and 1. And I'm going to put those numbers into my slope formula. Okay, so my x1 is going to be 1, my y1 is going to be 3, my x2 is going to be 2, my y1 is going to be 1. Substituting those values into my formula, I would get y2, this is y2 right here, sorry, which is 1, minus y1, which is 3, over x2 minus x1, so that would be 2 minus 1. Working that out, 1 minus 3 is negative 2, over 2 minus 1 is 1, so I would get the slope of mn is going to be negative 2 over 1. Okay, and I'm just going to leave my answer as a fraction. I can think of that definitely as negative 2 if I wanted to, but I'm just going to leave it as a fraction. Next I'm going to find the slope. Next I'm going to find the slope of LK. Okay, so I'm going to find the slope of line segment LK, which LK would be considered the third side of the triangle. Remember, MN is considered the midsegment of the triangle. So how am I going to do this? Well, I'm going to use the coordinates of L, which, according to my graph, is 2 and 6, and the coordinates of K, which has coordinates of 4 and 2. And then I'm going to put those numbers into my slope formula to find the slope. X1 is going to be 2, Y1 is going to be 6. X2 is going to be 4, Y2 is going to be 2. Okay, putting that in my formula. Y2, which is 2, minus Y1, which is 6, over X2, which is 4, minus X1, which is 2. 2 minus 6 is negative 4. 4 minus 2 is 2. I'm going to reduce this to negative 2 over 1. So you can see that the slope of LK is negative 2 over 1. Okay, so this says, part C, find the slopes of MN and LK using the slope formula. I just did that. You can see, here's my slopes right here. MN has a slope of negative 2 over 1. LK has a slope of negative 2 over 1. All right, I did that. Then it says, justify mathematically why they are parallel. Well, what do you notice about their slopes? Well, they're the exact same thing, okay? So what does that tell me? This tells me mathematically they are parallel. So we know that MN is parallel to LK. So those two line segments are parallel because these slopes are equal. Slopes are equal, okay? Mathematically, if slopes are equal, it means the two lines have to be parallel. That's how you would do part C. Part D, using the distance formula, and here's my distance formula right here, find the length of line segment MN. So we're going to find the length of the midsegment MN, and we're going to find the length of JK. Okay, so the first thing that I'm going to do is I'm going to find the length of MN. Now, how am I going to do that? Well, I'm going to need the coordinates of M, which we already determined were 1 and 3, and N's coordinates were 2 and 1. And then I'm going to take these numbered values and I'm going to put them into the distance formula. Remember, the word distance and the word length, those two mean the same thing. So, if the problem says find the length of MN, that means we're going to use the distance formula. X1 is 1, Y1 is 3, X2 is 2, Y2 is 1. Putting those numbers into my distance formula, I'm going to get the square root, then I'm going to have parentheses of X2, which is 2, minus X1, which is 1, close the parentheses, have a power of 2. Then I'm going to put an addition sign, plus, then I'm going to go Y2, which is 1, minus Y1, which is 3, and then I'm going to close the parentheses and I'm going to have a second power. So substituting these values into my distance formula, that's what I'm going to get. And now I'm going to work out this problem doing little steps at a time. Do the inside of the parentheses first. 2 minus 1 is 1. So now I get 1 to the second power plus 1 minus 3 is negative 2. Negative 2 to the second power. Okay, I'm going to do this little baby steps at a time. My next step is I'm going to raise each of these numbers inside the parentheses to the second power. Keep the square root symbol. So I'm going to get the square root. 1 to the second power is 1 plus negative 2 to the second power. Remember, that means negative 2 times negative 2. So that's positive 4. Then I add these numbers up, and you can see I get the square root of 5. Okay? So that means the length of m to n is equal to the square root of 5. Alright? So then my last step is I get out a handy-dandy calculator, and then I actually figure out what is the square root of 5 equal to. And with or without the glare, we're going to say it's 2.23. There we go. So we're going to say that the length of mn is 2.23. Okay, next we're going to find the length of LK. So we're going to do it the same way. We're going to figure out how long is L to K. So L had coordinates of 2 and 6. K has coordinates of 4, 2. Then I'm going to use those values and put them into my distance formula. x1 is 2, y1 is 6, x2 is 4, y2 is 2. Putting those into my formula, I'm going to get the square root, parentheses, x2, which is 4, minus x1, which is 2, close that parentheses, to the power of 2, plus another parentheses, y2, which is 2, minus y1, which is 6, close the parentheses, to the power of 2. Okay, then I'm going to take little baby steps to find the answer. My first step is I'm going to work out the inside of the parentheses. 4 minus 2 is 2. So I'm going to have my first parentheses becomes 2 to the second power, plus 2 minus 6 is negative 4. So negative 4 to the second power. Now I'm going to do the exponents, okay? Pretty much what I'm doing is, not pretty much, what I'm doing is I'm doing the order of operations. That's going to give me the square root. 2 to the second power is 4, plus negative 4 to the second power is positive 16. That's negative 4 times negative 4, positive 16. Add these numbers up, and you can see I get the square root of 20. All right? I work that out, and okay, so now I get a calculator out. I find out what is the square root of 20. And you can see, well, you can't see because I have a nasty glare there. There we go. So you can see the square root of 20 is 4 and I'm just going to write 4.47. Okay, I'm not going to write any more decimals past that. So 4.47. So what is the length of L to K? Well, that is 4.47. All right. Okay, part E. The length of m to n is blank, so how much is this length, m to n, of the length of L to K? Okay, from your work in part D, explain mathematically why this is true. Okay, so notice m to n, we got to be 2.23. That's obviously smaller than the length of L to K, which we got to be 4.47. So this is asking m to n is that, 2.23, m to n is how much of that? It is half. So the length of mn is half of the length of L to K. Okay? How do we explain that, why that is true? Well, I just did it up here. I did the distance formulas. So that's how you would do the first page. Okay? And this first page is, we're using our coordinates in geometry to prove this theorem. Okay? All right. Perfect. The lights went out in the city. The lights go down in the city. Great song. Extra credit if you can tell me who sings that song. Okay, number 2. The coordinates of the vertices of a triangle are A, negative 2, 3. So I'm going to plot that. That means left 2, up 3. There's A. B, which is coordinates of 6, 1, so that means right to positive 6, up 1, there's B, and I'll put the letters in a second. And C, which is 4, 5, so that means right 4, 1, 2, 3, 4, up 5. 1, 2, 3, 4, 5, okay? So there's A, there's B, there's C, And it says these are the coordinates of the vertices. That means these are the corners of a triangle. So I'm going to connect A to B, B to C, and A to C, and that will give me a triangle. Okay? So this is what my triangle looks like in number 2. And what I'm going to do is I'm pretty much going to do what I did in number 1. Notice that A says find the coordinate of the midpoint of AC, label it point D. Okay? So how do I do that? Well, A has coordinates of -2 and 3. C has coordinates of 4 and 5. I'm going to use the midpoint formula, which is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. That'll give me the coordinates. Okay? And I'm going to find that, and I'm going to label it as D. So D would be equal to x1, which is -2, plus x2, which is 4, divided by 2, comma, y1, which is 3, plus y2, which is 5, divided by 2. So that means D's coordinates are -2 plus 4, that's 2. 2 divided by 2 is 1. 3 plus 5 is 8. 8 divided by 2 is 4. So D's coordinates are 1, 4. So I'm going to plot this on my graph. I'm going to label it as D. Over 1, up 1, 2, 3, 4, right there, that is point D. B, find the coordinate of the midpoint of side CB. So I'm going to use C and B, and I'm going to label that point as E. Okay, so C's coordinates are 4 and 5. B's coordinates are 6 and 1. And once again, I'm going to use the midpoint formula, x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2, comma. I'm going to use that formula to find the coordinates of the midpoint, and I'm going to label it E. So that means E is going to be equal to x1, 4, plus x2, 6, divided by 2. Put a comma, because I'm finding coordinates. y1, 5, plus y2, 1, divided by 2. Okay, that will give me 4 plus 6 is 10. 10 divided by 2 is 5. 5 plus 1 is 6. 6 divided by 2 is 3. So that means E, which is the coordinate of CB, or the midpoint, excuse me, of CB, will have coordinates of 5, 3. So over 5, 1, 2, 3, 4, 5, up 1, 2, 3, right there, that is the coordinate, that is the point E. Okay, so what I'm going to do is I'm going to connect D to E. Okay, so what's D to E called? Whenever you connect two midpoints of a triangle, that is called the midsegment. Okay, and remember, so what's the rule of the midsegment? There's two things. That midsegment is going to be parallel to the third side, which is A to B. So D to E is going to be parallel to A to B, and then D to E should be half as long as it is from A to B. And we're going to show that in part C and part D. So part C says, mathematically show that DE is parallel to AB. So how do I show that things are parallel? Remember, we use the slope. So we use the slope formula, y2 minus y1 over x2 minus x1. I'm going to find the slope of DE, and I'm going to find the slope, sorry, I'm getting ahead of myself. I'm also going to find the slope of A to B, and if those two slopes turn out to be the same exact thing, that means the lines are parallel. Okay, so let's find the slope of DE. So D's coordinates, we found that up here, are 1 and 4. E has coordinates of, and we found that in part B, of 5, 3. We're going to use those numbers, put them into the slope formula. Okay, to find the slope of line D to E. So y2 is going to be 3, minus y1, which is 4, over x2, which is 5, minus x1, which is 1. 3 minus 4 is negative 1. 5 minus 1 is 4. So we just found out that the slope of line D to E is negative 1 over 4. we're going to do the same. We're going to find the slope of line A to B, the third side of the triangle. We're comparing it to the midsegment. Okay, so A's coordinates, we're going up here, we're getting them from previously, -2, 3. B's coordinates were 6 and 1. I'm going to use those numbered values and put them into the slope formula. Y2, which is going to be my 1, minus Y1, which is 3, over X2, which is 6. Here you got to be careful. Then it's minus X1, and X1 is -2. So I'm going to get a 6 minus a -2. Okay, now I'm going to work that out. 1 minus 3 is -2. Over 6 minus -2. Here we have a double negative, so that means plus. That's 8. And then I'm going to reduce that. That reduces to -1 over 4. Okay, so now we could see that both slopes were -1 over 4. So the slope of D to E was -1 over 4. The slope of line A to B was -1 over 4. Have I mathematically shown that DE is parallel to A to B? Yes, I have. The slopes are equal. When slopes are equal, that means the lines are parallel. Part D, mathematically show that the length of D to E is half the length of side A to B. So now I'm going to use the length, okay? So how do I mathematically show the length? Well, I use the distance formula. Square root, parentheses, x2 minus x1 to the second power plus y2 minus y1 in parentheses to the second power. Okay? So the first thing that I'm going to do is I'm going to find the length of side DE. Then I'm going to find the length of side AB. I'm going to use the distance formula to find the length. Length and distance mean the same thing. And then hopefully whatever I get for this number is going to be half of whatever I get for that number. Okay? So D's coordinates are 1 and 4. E's coordinates are 5 and 3. I'm using their coordinates to get my x2, my x1, and so on values. Okay, so that would give me the square root of x2, 5, minus x1, 1, close the parentheses to the power of 2, plus, start a new parentheses, y2, 3, minus y1, 4. Close the parentheses to the second power. Now remember, I work this out step by step, little baby steps at a time. Do inside the parentheses first. 5 minus 1 is 4, so I have 4 to the second power, plus 3 minus 4 is -1. So now I have -1 to the second power. Then we do the power of 2's. Okay, keep the square root. 4 to the second power is 16, plus -1 to the second power is +1. Add those numbers up, we get the square root of 17, and now you use a calculator to give you what the square root of 17 is. And if you get a really long decimal, and you could see I get a really long decimal, just write the numbers, 2 numbers after the decimal, 4.12. Okay, that's to the hundredth spot, we call that. So I just got the length of D to E to be 4.12. Okay, now remember, D to E's, hopefully that number is going to be half of this number. So what should this number be if that's half? Let's double that, 8.24. This answer, when I do the distance formula, had better be 8.24 or like 8.23 or something like that. Okay, let's see if we can do it. So A as coordinate, I'm going to use the coordinates of A, -2, 3. I'm going to use the coordinates of B, which are 6, 1. And now I'm going to put those numbers into the distance formula. Square root. X2, that's 1. No, that's 6. Sorry. So you got to be careful when you do this. Minus X1. Now X1 is -2, so it's 6 minus -2 to the second power. Plus Y2, that's 1. Minus Y1, which is 3 to the second power. Okay, so now I work this out in baby steps, step by step. Inside of parentheses first, 6 minus -2, that's like 6 plus 2, that's 8. So I get 8 to the second power, plus 1 minus 3 is negative 2 to the second power. Now I do the second powers. Keep the square root. 8 to the second power is 64, plus negative 2 to the second power. Remember, that means negative 2 times negative 2, so that's positive 64. And then I add those up. So I get, you can see, I get the square root of 68. And then I use my calculator to work that out. Now remember, hopefully whatever that is going to be right around 8.24. It's going to be, that number is going to be half of that. So let's see if we get it. The square root, make sure you can see it, okay, of 68. Boom, 8.24. All right, I did it right. So mathematically show, I just mathematically showed that the length of D to E is half of the length of A to B. 8.24, 4.12 is half of 8.24. All right, moving on to number 3. Now we're going to apply what we just learned. Okay, so we're not going to have to use the formulas anymore. We're just going to apply the rules that we learned. So B is the midpoint of AC. So we know B is the midpoint of AC. I'm going to put tick marks to show that I know it's the midpoint. D is the midpoint of A to E. So I'm going to put tick marks here. I'm going to use double tick marks just so I know D is the midpoint between A and E. The measure of angle ADB, so ADB, that means right there, that angle is 70 degrees. I'm going to mark that. The measure of angle C is 60. Okay, so that angle right there, 60. And B to D is 12. So that right there is 12. We're going to find these 4 things. The first thing, we're going to find C to E. So how long is that right there? Okay, well, that is called a midsegment. The midsegment has 2 rules with the third side of a triangle. Remember, it's parallel to the third side and it's half. So that's 12, that's half. So what does C to E have to be? It has to be 24. Okay, how did I get that? You would just go 12 times 2. So C to E is equal to 24. Okay, next we're going to find the measure of angle E. This is angle E right here. I'm finding that angle right there. So how do I find that? Well, remember, this midsegment is parallel to the third side of the triangle. So that means these 2 angles have to be equal because they're corresponding angles. We've got our parallel lines, we've got our transversal. So that means the measure of angle E would have to be 70 degrees, which is equal to the measure of angle D, 70 degrees. C, what's the measure of angle ABD? ABD, so this angle right here. Okay, that angle is equal to this angle up here for the same reason that those 2 angles were equal. They're corresponding angles, so that would be 60 degrees right there. Okay, and the last one, what's the measure of angle A? Well, to find angle A, I could use this triangle right here. Remember, the 3 angles in a triangle add up to 180. So I would go 60 plus 70, that's 130, and then I would subtract 130 from 180, because the 3 angles in a triangle add up to 180, so I get 50. So the measure of angle A is 50 degrees. There we go.